Right, so in this lecture, we are going to look at the Physics 101 practical B1. Now you have the topic of the practical, the title is measurement with calipers, screw gauge, the stopwatch, and estimation of various errors. The length of the meter rule was given to you 100 centimeter. All right, now you were asked to measure this with what we call a vernier caliper. All right, a vernier caliper is a measuring instrument that can be used to measure small length. Now, the length of the meter rule was given as 100 plus or minus. Now, this plus or minus states the maximum estimated error for this measurement, or maximum error. And for micrometer screw gauge, the maximum error is either 0.1 millimeter or 0.01 centimeter. Is that okay? So if it is 0.1 millimeter, what does that mean? It means that all your values, if the the vernier caliper, no, did I say micrometer screw gauge? No. The vernier caliper is usually calibrated either in millimeter or centimeter. Now, if it is calibrated in millimeter, it means all these values you have here will be in millimeter. But most of you don't even know the calibration. But I put the two there, millimeter or centimeter, based off your value. But if it is actually calibrated in millimeter as it should be, all these values here should be in millimeter. All right, that is the breadth of the meter rule. Now, as a matter of fact, I don't think there is any meter rule that the breadth is. Let me check. Normal meter rule. Call me. Think I should have 1 meter rule in my bag. Oh my God. I can't find it. I should have a meter rule in this bag. Can't find it. Or did I drop it on top of this table? It's not here. All right. But if it is in centimeter, you also have your readings in centimeter. Why? If it is in millimeter, you also have your reading in millimeter. Now, 10 measured values of the thickness. The thickness was given as 0.6 centimeter, 0.6 centimeter, and so on and so forth. So if your answers are in centimeter, please write this as the maximum error for the length. Is that okay? So these are the values that we are given in the first one. Now, individual values will differ from persons to persons. Is that okay? Now, the next one is reading error of the screw gauge. Now, most times your micrometer screw gauge is calibrated in millimeter, and the reading error in micrometer screw gauge is 0.0 millimeter. Is that okay? 0.0 millimeter or 0.01 millimeter. Or if you want to convert this to centimeter, it's 0.001 centimeter. Now, 10 measured value of the diameter D. The diameter, you have your measured values already stated in your manual. I believe most of you already have your values. Then 10 measured value of the length of the wire was also given to you. Then the reading error of stopwatch. Some of you said you are given 0.5 seconds. And your values that you have here are 14.74, 2 decimal place. And your error here, 0.5 seconds. It doesn't make any sense. The reading error of the stopwatch is supposed to be at least 0.0, either 0.05. But I believe most of you did not use that stopwatch that was supplied in the laboratory. You use your phone as the stopwatch. And the reading error of your stopwatch in your phone is around 0.05 or 0.01 seconds. So you should write all these values. But if they give to you 0.5 seconds, you can write 0.5 seconds in your manual. And then they gave you 10 values of time t for 10 oscillation and corresponding periodic time. Now, they gave you these values for 10 oscillations for each of them. 14.76, 14.70, this for 10 oscillation. Now, what do we say is period? Period t is equals to time divided by number of oscillation. Now, in this case, to calculate our period, it will be t, number of oscillations is how many? 10, which is t over 10. And t over 10 will give us 1.476, which is 14.76 divided by 10. Because it's a measured value, add 0 to before decimal place. So this will be 1.4760. Divide this by 10, it's supposed to give you 1.470. But because it's a measured value, I mean it's a calculated value rather, you add 0 to it, so before decimal place. So that is what you are going to do for the rest 10 of them. Now, if your number of oscillation was changed to 20, it means these values here, you are going to be dividing all of them by how many? 20. Is that okay? All right, so that is that. Now, they now ask you a question. Use the space below to state the appropriate formula and calculate the following. 1. The volume of the meter rule and its maximum error. Now, my dear student, the meter rule is like a rectangle, and the volume of a rectangle is length times breadth times the thickness, k. All right? The length times breadth times the thickness, k. Sorry. This is supposed to be the thickness, k, and this L value is 100. Now, my dear students, you see the length, the thickness was measured severally. So you are going to find the mean value for the thickness. And we can say that the mean value will be the sum of everything here divided by 10. Divided by number of measurements, which is of course 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we say 10 times this will give us, when you add everything here together, it's going to give us 6.0 divided by 10. 6.0 divided by 10 will give us what? 0.6. So the mean, the reason why it gave us exactly 0.6 is because all of them have the same value. So the mean of the thickness is 0.6. All right, the reading error of the vernier caliper in centimeters still remains what? 0.01 centimeter. That is the maximum error. Now, for this one, if you are using centimeters, since they say the length of the meter is 100 centimeter, this one will also be 0.01 centimeter. Then for B, you find the mean of this value. How do you determine the mean of this value? You add everything there, then divided by 10. Now, I'm going to add them. 3.7 plus 3.9 plus 4.3 plus 3.5 plus 4.3 plus 4.1 plus 4.3 plus 4.2 plus 4.2 plus 3.6 divided by 10, which is 4.01. So this will be 4.01 plus or minus. The reading error for this one also will still remain 0.01 centimeter. What this value is telling us is that the highest value can either be 4.0 plus 0.01, or the lowest value will be 4.0 minus 0.01. Same thing applicable to this one. This one will be, we already wrote this one, 0.6 plus or minus 0.01 centimeter. So what do you think is the volume? Say volume is what? Length times breadth times the thickness, which is the height. So volume, the length is 100, the breadth is 4.01, the thickness is 0.6. Now, my dear student, if you calculate this with your calculator, that will give us 100 times 4.01 times 0.6, which gives us 240.6 centimeter cube. Is that okay? Now, some persons may be asking me, how did I get 0.01? The vernier caliper, the maximum error of the vernier caliper is 0.1 for each of these measurements. So when you are measuring using the vernier caliper, the maximum error that can give to you is 0.01 centimeter. In millimeter is 0.1 millimeter. That is why these values I'm always putting plus 0.01 centimeter plus 0.01 centimeter. All right. Now, the next question says the maximum error in V. Now, my dear students, how do you calculate the maximum error in V? Now, what is V? We said V is equal to, sorry about that, let me arrange. V is equals to length times breadth times thickness. The thickness was given as K. So if you want to find the maximum error, you are going to use E to represent error. The maximum error in V will be the maximum error in V divided by V is equals to maximum error in L divided by L plus maximum error in B divided by B plus the maximum error in the thickness divided by the thickness of the wire. So the maximum error in V would be equals to V bracket error in L over L plus error in B over B plus error in K over K. Is that okay? So the maximum error in V, what was the volume we just calculated? 240.60. So we have 240.6. Now what is the error in L? 0.01 divided by, what is the value for L? 100 plus error in B still 0.01 divided by, what is our B? The value we calculated for the breadth, 4.01. So we have 4.01 plus error in thickness still 0.01, because we said that is the maximum error for that vernier caliper. Then divided by, what is the value? 0.6. So we have 0.6. Is that okay? Now, so when you now calculate this value, what do you think is going to give to us? It's a very simple something. Let's see. We'll put 0.01 divided by 100, which this first case gave us EV is 240.6 bracket 0.001, okay, another 0 before 1, plus we'll have 0.01 divided by 4.01, which gave us 0.0025 approximately, plus the last one is 0.01 divided by 0.6. This one gave 0.01667 approximately. So EV, which is the error in the volume, will be 240.6 bracket every other value you have there is 0.001 plus 0.0025 plus 0.01667, which gave 0.01927. Now when you multiply this by 240.6 times 240.6, that will give us 4.63. So the maximum error in the volume is 4.63. So it's better you write the value for the volume to be V is 240.6 plus or minus 4.63. Is that okay? So that is how to go about something like this. Let us see the next one. The next one, it's about the diameter of a wire coming. All right, so the next question says the mean diameter of the wire D and its standard error. This is the diameter of the wire you measure. Some of you measured this. Some have their own different values. So if you want to find the mean, what is the formula for mean before now? We said mean is equals to, add everything here together, 0.75 plus 0.75 plus 0.75 plus 0.75. This is so tiring. 0.75 plus 0.75, 1, 2, 3, 4, 5, 6, plus 0.75 plus 0.75 plus 0.75 plus 0.75, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All divided by 10. If you add everything there together, it's going to give us 7.5 divided by 10, which will give us 0.75. So the mean is still the same thing as the value you got. All right, is in millimeter. Now, they now ask you to calculate the standard error in the mean. Now, to calculate standard error in the mean, use W all over N, where N is the difference between the highest value divided by, where W is the range of the value. The range of the value is the difference between the highest value and the smallest value. Now, in this case, all the values are the same. So the standard error will definitely be what? 0. Tell you that there's no error. But some of you may have variation. So our standard error of the mean will be 0.75. That is the highest. The lowest is also 0.75. All divided by total number of value here is our N. Is that okay? Which is 10. This is the formula for calculating the standard error of the mean. So when you subtract these two, this will still give us 0.00 or 0.0 divided by 10, which should be 0.00. Now, what does this tell us? This is telling us that the mean has no standard error. So you write 0.00. Depending on the unit you use, if it is centimeter or millimeter, I believe it should be in millimeter, you put 10 millimeter. Is that okay? So that is the mean diameter and the standard error in the mean. Now, there are some of you that your values might significantly differ from each other. Let us assume here you have values like 0.65. Then the highest value is 0.75, and then there are other values like 0.7 in the middle. The highest value here will be what? To calculate the standard deviation of the mean in that case. Highest value is 0.75, lowest value is 0.65, which will give us 0.75 minus 0.65 divided by 10, and then you get your answer. But for this one, all the values are the same. So your standard deviation will be 0. Now, the next question says the resistance of the wire and its standard error. Demonstrator to supply specific resistance. Now, my dear students, when they ask you to calculate the resistance of the wire and its standard error, now what is the formula for resistance? Resistance is resistivity times length over R, where R is the area. E is the resistivity, L is the length, and then A is the area. Now, the area is calculated as pi d square all over 4. That is the formula for calculating the area of the wire, pi d square over 4. Now, we are going to use the mean diameter, which is 0.75. So we can say area is pi. Pi is what? 3.142. D is what? 0.75. And then what are you going to do? You square it divided by 4. Is that okay? Now, at the end of the day, what are you now going to see? You are going to have 3.142 times 0.75 square divided by 4, which is 0.441. This is our area. All right. The next thing is the length of the wire. Now, what do you think is the length of the wire? The length of the wire was given to you from there. You measured the length of the wire to be 10.3, 10.3, 10.3 all through. You got the same value. Although there ought to be variation, but since you got the same value of 10.3, you are now going to say length is 10.3 millimeter. Depending on what you did, if it is centimeter, if it is millimeter, you write it as it is. All right, let me just use 10.3 and not put units. But depending on the units you actually used for your measurement, is that okay? Which is 10.3, could be millimeter. Now, my dear students, the next thing is the resistivity. How do you calculate the resistivity? Now, to calculate the resistivity, we use the formula. What is the formula we are going to use to calculate the resistivity? R is equals to, the resistance rather. R is equals to resistivity. The resistivity was not provided for you, but I know you should use a copper wire, and therefore I use a standard value for copper wire. Although this value is supposed to be provided as stated in the manual that demonstrated to supply a demonstrator to supply specific resistance. Specific resistance is resistivity times the length is 10.3. Although you are supposed to find the mean value for the length. However, since all the values are 10.3, it means the mean value will also fall on 4.3 divided by the area, which is 0.441. So the resistance would be equal to, if you punch this in your calculator, it will give us 1.68 times 10 to the power of minus 8 times 10.3 divided by 0.441. Okay, let's not multiply by this times 10 raised to the power of 8. Okay, this one gives us 39.2 times 10 raised to the power of minus 8. Now, if you count backward once, you add 1 to the power. So our resistance is 3.92 times 10 raised to the power of minus 7. Now, what is the formula for resistance? Resistivity is ohm meter. All right. Length is in length. We said the length this time is in millimeter. Area is in millimeter square. All right. So this cancel this one, this cancel this, you are left with millimeter. The formula for resistance is this. So the formula for, the unit for resistance will be ohm. From unit analysis I just did. Ohm. So that is your resistance of your wire, and that is the formula for resistance normally. Now, the next question is calculate the standard error in the resistance. You've calculated the standard error in the diameter. You also calculate the standard error in the length. Now, the standard error in the diameter gave us 0. The standard error in the length will also give us 0 if we follow that procedure. So let us calculate the standard error in the resistance. Now, what is the value for the resistance? We said, okay, the value for resistance, let me write it out, is 3.92 times 10 to the power of minus 7. What is the value for the length? 10.3. What is the value for the area? 0.4411. Of course, this is supposed to be millimeters square. This is millimeter. All right. Now, my dear student, what are you going to do now? You are now going to calculate the standard error. Now, how do you calculate standard error when quotients are given to you? It's very easy. Since there is no thing in the formula that is carrying power, you are going to use this formula. Standard error in the formula is what? R is resistivity times length over A. So this will be standard error in R over R is equals to standard error in resistivity. This is supposed to be resistivity under all over resistivity plus standard error in length over length plus standard error in area over area. Is that okay? Exactly. Now, each of these values are squared. So this one will be squared. This one will be squared. This one will be squared. Now, I already taught you how to calculate the standard error in each of the measurements. You use this formula. So if your own is not 0, I already know that from this measurement they got for the length, the standard error will end up to be 0. I mean, this particular measurement here, because it's 10.3, 10.3, all the values are the same. So the standard error will end up to be 0. But if your own did not end up to be 0, maybe you have variation, you use this formula to calculate standard error, which is W all over N. So if you want to calculate the standard error for the length, it will be W. W is the difference between the highest value and the lowest value for the length, and then N is the number of values that you have there, of course, is 10. So, and then also, this one is squared. Is that okay? So that at the end of the day, from propagation of error and what you guys already learned, you were taught that this particular one will give us the R square if you find the square root of both sides. So the standard error in the resistance, right, will be equals to R outside, that is finding the square root of both sides. Are you getting it? R outside, then all bracket, standard error in this, all this on squared, plus standard error in length, all over length squared, plus standard error in A, all over A square, all square root. Told you that you find the square root of both sides. That is what this is going to give to us. Now, for each of the things you have here, We said the resistivity is what we just calculated. And we are looking, resistance. And we are looking for the standard error in the resistance. But the resistivity is a constant. And because it's a constant, you don't include it. Are you getting it? So we are going to remove this one from here. Resistivity is a constant, and because it's a constant, you don't include it. So the standard error will only be contributed by this and this. Now, my dear student, what do you think will be our answer? It's a very simple something to do. Oh, guy, erase. So our standard error in resistance will be the square root of what we calculate as the standard error in length. We said my battery is low, 0. The length is what? 10.3 all squared plus what is standard error in area? We said that the standard error in area, what did we calculate as our area? We've not calculated the standard error in area, but we can actually calculate that. Area is pi d square over a. Pi d square over 4. Pi is constant. D is the only thing. So from the standard error in D, you are supposed to get the standard error for A. Are you getting it? And when we measured our diameter, the standard error in the diameter also gave us 0. So we can say that this will also be 0 divided by, what was the area we calculated for? 0. The area has a value now. What was the area of the value of the area we calculated? I didn't write it down. Oh. The value for area, I didn't write it down. But you already have the value for area. Pi d square over 4, which is pi is 3.142 square. Okay, pi d square times d. D is the mean diameter, 0.75 square divided by 4, which gave us 0.441. So this is 0.441 all squared. Now, my dear student, if you do this calculation, everything here is going to give us 0 plus 0, and your SRO will be equals to 0. So the standard error in the resistance of the wire is 0 based on this calculation. All right, so the next practical is still the same thing, but this one they ask for the mean periodic time T and its standard error. Now when they say the mean periodic time, you are talking about the mean period. Now we already calculated the period earlier here by dividing the time by the number of oscillation, which give us these values. So we want to find the mean of all these values here. Now how do we find the mean? Of course, every one of you know the mean. So we can say mean of T. All right, so we can say the mean of T would be equals to, you add everything here together. Is that okay? You add everything you have here together and then divided by the number of oscillation, which is 1, 2, 3, not number of oscillation, divided by the number of values you have here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's add everything there together. It gives us 1.476 plus 1.470 plus 1.474 plus 1.477 plus 1.486 plus 1.495 plus 1.464 plus 1.484 plus 1.475 plus 1.457, all divided by 10. It gave us the mean to be 1.4758. So this is the mean of this measurement. And then they say the standard error. Told you that the standard error of the mean is W over N. In this case, our N is equals to 10. What is our W? The differences between the highest value and the smallest value. Now, I believe the sorry about that. I believe the highest value in this measurement is 1.495. Is there any value higher than that? So it becomes 1.495 minus, what is the smallest value in this measurement? I think the smallest value is 1.4, is there 1.46? Yes, 1.46. Okay, there's 1.45 even. The smallest value is this value here, which is 1.4570. So our W will be equal to, when you subtract 1.495 minus 1.457, that will give us 0.038. So this 0.038 now give us the range of values. Is that okay? Which is our W. So our SM would be equals to 0.038 divided by 10. And of course, this will give us 0.0038. So our standard error for the mean is 0.0038. So if you want to write the mean value now, you can say it's 1.4578 plus or minus 0.0038. Is that okay? So that's the answer to that question. Let's see the next one. The next question says the value of G using the formula T is equals to 2 pi bracket L over G raised to the power of half. Now, all of you here, we are going to have different values. This T, the period, was what you got from your table initially. There's a table that was given to you in question 4, 10 values of time T. So you already have your table. You already have your T value. To get the period, you divide by what? 10, because it's not 10 oscillations, which gave you the value under. And from that value under, that was where we are able to get our highest value and our lower value. Is that okay? All right. So the next says the value of G using the formula T is equals to this. Now, formula T is 2 pi root of L over G all to the power of half. You can square both sides. If you square both sides, T square would be equals to square here. 2 square is what? 4. Pi square is what? Square. 4 pi square. And then you have L over G. Because the square is going to cancel this half from here. Is that okay? We want to make G the subject of the formula. So cross multiply. T square times G will give us what? T square G is equals to what? 4 pi square L. Is that okay? Now, to get G, divide both sides by T square. So T square cancels T square. G would be equals to 4 pi square L divided by G at T square. T square is what? Is, I think, T square. Now, what is pi? Pi is 3.142. square times L. The length was given as 50 centimeter. Now your time is in seconds. Centimeter and seconds might not really go well like that, but let us just put it because 50 centimeter. All right, let's work with the centimeter. Divided by seconds. Time is in seconds. The period, rather, is in seconds. Now, what was the mean period we calculated? 1.4578. So you are going to come here and say 1.4578. You know your G is supposed to have a value. So at the end of the day, you are going to have, press your calculator, I'm pressing it direct, 4 times 3.142 square times 50 divided by 1.4578. That gives us 1354.39 centimeter per second square. All right, that is our value for G. Is that okay? Centimeter per second square. Is that fine? Oh, I made a mistake. I didn't actually square this value you have here. All right, we didn't square this. So please, let me square this and see the answer it will give to us. All right. 92, which is an approximate value, which you guys are most correct. 929.066. 06 or 058 centimeter per second square. So this is the value for our G that we calculated. Is that okay? That's the value for G calculated in centimeter per second square. So now the next question is calculate the standard error in G. How do you calculate the standard error in G? Firstly, what was the formula for your G? Your G is 4 pi square L all over T square. So I'm going to write out the value of G as calculated first, which is 929.0658. Now, I'll write out this value and then erase every other thing on the screen so that. All right. Now, the formula for G we calculated was G is 4 pi square L over T square. It means that the value of G are influenced by L and T square. Is that okay? Now 4 pi square, they are constant. So to calculate the error in G, we are going to say error in G, standard error in G, all over G is equals to standard error in L all over L. Please let this one be squared. Is that okay? Squared plus the standard 2 times, because of this T square here, you are going to put 2 times the standard error in T, 2 times standard error in T all over the value of T all squared. That is what the process we are supposed to use, and that is the correction that I actually want to make in your notes, because most of the error in G we are actually calculating the error in the slope, not error in G. So how do we now get the standard error in G? If we find the square root of both sides, my dear student, find the square root. The square root will cancel this square from here, right? So here we give us xg over g, because the square root will cancel the square from here. And then you are going to have SL over L. This SL means standard error in length, subscript L square, plus 2 times standard error in T all over T all squared. Now to find, you say you square rooted both sides, Abi, so you're also going to square root this, so that our SG will be equals to G bracket the square root of standard error of length, standard error in L square, plus 2 times standard error in T all over T squared. Now, my dear student, what was the standard error in the length? Does the length actually have a standard error? The length is constant throughout the practical. Are you getting it now? Now, since the length is constant throughout the practical, it means it does not have any error. So we are going to remove the length. Is that okay? Because it was constant during the practical. You didn't change your length. So we can say that the standard error in G is equals to G, then bracket square root of 2 bracket standard error in T all over T, everything here squared. Now, SG, what was your G value? 929.0658 times, or bracket, the square root of 2 times. The standard error in T was this value you calculated here. The standard error in the mean period, which is 0.0038. So you are going to say times 2 times 0.1338, 0.038 divided by T is the time. The period, the mean period is what? 1.4578. 1.4578. Now, everything here is squared. Is that okay? Now, this square here can cancel out the square root, so we don't need to really write all those stuff again. So our standard error in G would be equals to 929.0658 times, simplify everything inside that bracket. What would that give to us? Let me open a bracket here. We have 2 times 0.038 divided by 1.4578. Was that what we got here? 1.4578. 0.0. How many zeros? 2 zeros. So it's supposed to be 0.0038. All right. Now the answer I gave was 0.0052. So this multiplied by 0.0052. Now, if you multiply 0.0052 times 929.0658 to give us 4.8435. So this is our standard error in G. So our G value now will be equals to 929.0658 plus or minus 4.8435. You can also check for any error to see if we actually made any error anywhere during the course of the calculation. All right, you can check if we made any error anywhere during the course of the calculation. All right, so that is that. Now, use the space below to state the appropriate formula and calculate the following. Okay, we already did that. Which is more accurate, one measured value of a diameter of the wire or the mean of 10 measured values? Give reasons for your answer. Now, my dear students, I believe everybody understand what I did here. So the standard error, this 4 pi square is constant. Errors are only brought about by variable. That means things that change. 4 pi square is constant. So the only thing that can bring the error is the length and a period. Now we are now saying that error in G all over G squared is equal to error in L all over L squared plus what? Because of this square here, that is why we have 2 times error in T all over what? T and then everything squared. Then you did your calculation. Then the reason why I remove L is because you have only one measured value of L, so there could be no error from the length. That is the reason why it landed us only on T. Is that okay? Now, which is more accurate? One measured value of diameter of the wire or the mean of 10 measured values? Give reasons for your answer. Now, 10 measured value is more accurate. Now, using the mean of 10 measured values provide a more reliable and accurate estimate of the wire's diameter compared to relying on one measurement because it increases precision, minimizes the effect of both random and systematic error. If you measure 10, they say the more the merrier. As plenty reach, you will actually get the one when you find the mean, you notice that the mean is very close to the actual value. So this is what you are going to write there. Then the next one. State your realization of the aims of the experiment in the space below. Now, the aim, the realization, more like a conclusions. The practical successfully demonstrated the importance of repeated measurement, careful calibration, and error estimation in achieving accurate and reliable results. The calculated mean values and the estimated errors give a clearer understanding of the precision and accuracy of our measurements. This approach ensures that the data obtained is robust and can be confidently used for further analysis or application. Is that okay? So that is everything for this B1 practical. We'll see you in the next one. Bye-bye.